Welcome back to part 2 of section 2.1. We're solving systems using the echelon method. And here we go. We have another system of equations. My job is to solve it using the echelon method. First step is to remove the first variable from the second equation. So I'm going to leave the first equation alone. But I need to remove the first variable from the second equation. So I got to get rid of the x's in the second equation. So it looks like if I take equation 2 and replace it with the old equation 2 minus 2 times equation 1, that should do the job. So over here under my scratch work, I'm going to take the old equation 2 and I'm going to subtract off 2 times the first equation. So 2 times the first equation, 2 times 3x would give me 6x. 2 times 2y would give me 4y. And 2 times 5 would give me 10. And I'll subtract. So 6x minus 6x is going to give me 0 x's. 4y minus 4, I get this. I get this nonsense sentence when I try to do this. I get the statement that says 0 is somehow equal to negative 2. Now that's not a true statement. So one of two things has happened here. Either I have made a mathematical error, which I'm going to go back and check. Let's see, here's my system. I'm taking equation number 2, 6x plus 4y. So this looks good to here. That's equation number 2. I'm subtracting off 2 times the first equation. So taking this first equation and multiplying it by 2, 3x, 6x, 2y, 4y, 5, 10. I'm subtracting. 6 minus 6 is 0, 4 minus 4 is 0, 8 minus 10 is negative 2. So that's correct mathematically. So that means that something's wrong with my system. So what does that mean? Well, what that means is that our system has no solutions. Since this is a 2-variable system, essentially this means that these are 2 lines with the same slope but different y-intercepts. 2 parallel lines that don't intersect. That's what we're looking at here. If it was a higher variable system, and I got a gobbledygook answer like that, it would just mean that in that higher dimension, things were parallel. Our system has no solutions. So the answer here is that there is no answer. The answer is that our system has no solutions. Now, depending on how good you are with your algebra, you might have been able to look at the original one and see that. You might have been able to look at the original system of equations and have noticed that the coefficients in the second equation are the coefficients in the first equation times 2. But the intercept, the constant values over here, which control the intercept, is not that same ratio. Okay? And what I mean by that, has that been a 10 down there, then everything would be times 2. And then something else would have happened. But because we have 2 equations and the coefficients are in ratio but the constants are not in ratio, it means that we have a system that has no solutions. How does the math tell me that? Well, when I'm trying to solve and using those proper solving techniques, I get this nonsense statement over here that somehow 0 is equal to a number. So whenever I see in my work, whenever I see this show up, that 0 is equal to a number that is not 0. 0 is equal to a positive number or a negative number. It doesn't matter, just some number not equal to 0. That tells me my system has no solutions. Okay? But just to review, you'll notice that I didn't just jump to the no solutions answer. I checked my work first to make sure I didn't make a mistake. Okay, so check your work, make sure the math that you did is valid, and then say, oh, since my math is valid, this system has no solutions. All right, let's try another one. Okay, all right, let's see what's going on here. I'm gonna do the same thing I did before. I'm going to eliminate the first variable in the second equation. So my first step, I'm gonna leave the first equation alone. I've got 3x minus 2y is equal to -4. And then my second equation, I am going to, let's see, I'm going to take equation number 2. And let's see, it looks like if I took the old equation number 2 and added 2 times equation number 1 to it, that would eliminate. So over here under my scratch work, I'm taking the old equation number 2, and I'm going to add 2 times equation 1. So 2 times 3x is 6x. 2 times -2y is -4y. And 2 times -4 is -8. And then I'm adding these together. 6x plus a -6x there gives me a 0x. Uh-oh. Do you see how I'm getting 0 again on the left-hand side? But now what did I also get on the right-hand side? I got 0 on the right-hand side as well. Okay, again, something weird is happening. So I'm going to check my work. Let's see. I copied this one down right, so that's good. I'm doing equation number 2 plus 2 times equation number 1. That's equation number 2. I copied that correctly. That is 2 times equation number 1, so I did that correctly. -6, +6, 0, -4, +4, 0, -8, +8, 0. That's correct. So what does that mean? Well, this now means that we have, what's going on there? My pen is acting weird all of a sudden. I'm going to pause. Okay, that was weird. It crashed and I had to restart it. So that means that we have infinitely many solutions. Now, what does that mean? Well, basically what it means is, since these two equations, when we work on them, we get the statement 0 equals 0, it really means that those are the same equation, and that infinitely many solutions exist because any point that satisfies the first equation would also satisfy the second equation because they're mathematically identical. Now, to simply say we have infinitely many solutions is not sufficient, because we are beyond that now. What they want us to do, or what we need to be able to do here, is we need to be able to do something called parameterize the solutions, or the solution. Okay? All right, now there are two different ways to parameterize the solution. We can parameterize it on the variable x, or we can parameterize it on the variable y. I will show you both so you can see. Okay? If I'm going to parameterize on x, then what I'm going to do is I'm going to make the following argument. That since both equations are the same, that any value that satisfies the first equation will satisfy the system. So meaning if you told me what x was, like let's say you told me that x was 2, could I plug in a 2 there and find a value for y? Or if you told me that x was 4, could I plug in a value and find y? Or if you told me that x was 5, could I plug in a value and find y? And so parameterizing on a variable means that we are going to write the system in terms of the system solution in terms of that variable. Right? So I'm going to solve for y, and that gives me negative 2y equals negative 3x minus 4, or that y equals 3/2 x plus 2. And then I will write the solution to the system in this way. X, comma, 3/2 x plus 2. And I parameterized it on x. Right? At this point, if you tell me what x is, I can tell you what y is. Right? So if you told me that x was 0, I would tell you that y is 2. If you told me that x was, I don't know, 1, I would then plug in a 1. 3/2 times 1 is 3/2. 3/2 plus 2 is what, 7/2? If you told me that x was 4, I would tell you, okay, plug in a 4 there. 3/2 times 4 is 6, so 8, and so on and so forth. So I have parameterized the solution on the variable x. As if this isn't complicated enough, you could also parameterize on y. Meaning if you told me y, then I could find the value for x. To do this, I'm going to solve for x. And so that gives me 3x is equal to 2y minus 4, or that x is equal to 2/3 y minus 4/3. And then I would write my solution and say it's 2/3 y minus 4/3, comma, y. And now if you tell me y, I can plug it in over here and get you x. Like if you told me that one solution was when y was 2, I'd plug in 2 over here and I get 2/3 times 2 is 4/3, and 4/3 minus 4/3 is 0. You'll see that I get the same solution here as I would there. It's just, what did you tell me? What is the free variable? Some refer to it as that. And then what is the dependent variable? So here, the free variable is x, the dependent variable is y. Here, the free variable is y, and the dependent variable is x. Right. All right, so let's back up and go back to where we started. Someone handed me a system and asked me to solve it. They said, here you go, solve this. I did math, and I got this. I did logical, appropriate mathematics, and I got the statement 0 is equal to 0. 0 is equal to 0 tells me that I have infinitely many solutions and that I'm going to have to parameterize my solution. I parameterize it on whichever variable they tell me. Parameterizing means to solve for that other variable. So if I'm parameterizing on x, I'm solving for y in terms of x. If I'm parameterizing on y, I'm going to solve for x in terms of y, and then write my system solution as an ordered pair, but algebraically. Okay. And then I get an equation, essentially, a formula would be a better way to say it, for the other variable. So if I'm parameterized on x, I know x, and I have a formula for the other variable in terms of x. If I'm parameterized on y, I know y, and I have a formula for the other variable in terms of y. Okay. All right, I'm going to end this video here. We'll come back and start the slightly more complicated examples when we do video number 3.